Well, here we are. It's another video. Let's talk about estimation of whole numbers and mixed numbers. Yeah. My new intro. Um, Welcome, y'all. Welcome back. As you can see today, we're going to be talking about the estimation of whole numbers and mixed numbers, and not just them in general, but the idea of how do we estimate the products of these things. So again, thinking about how we are going to multiply. Before we move forward, just for the record, that is not the new theme song. Just made that up. And I bet you all wish I wouldn't have. And I'm maybe wishing right now I wouldn't have had. But then again, maybe I'll sing some more today. We have no idea. Who knows what's in store? The only thing we do know is by the end of this video, we are going to be able to make sense of what happens when we have to multiply whole numbers and mixed numbers, but not only getting a direct answer, but really thinking about the estimation. So let's break all that down because I love to break it down. Estimation, right? When we hear estimations, we think about that word about. When we think about that word about, we are thinking really about rounding, right? We're getting an answer that's close to the real deal, not the deal itself. So again, today our example would be then, well, what happens if someone says, oh, well, I would love to know what happens if I take something like 5 and I multiply that by 3 and 9/10, right? Okay, cool. Well, let's think about that. If we break this down into steps today, we are going to round the mixed number. And then we are going to multiply. And then we will be finished. It's not really a step. We'll be done. So again, let's think about that. Step 1 here, right? We're going to round the mixed number. So the first thing I see here is a 5. That is a whole number. I don't need to worry about that. So I'm going to keep that as 5. And I'm going to multiply this by 3 and 9/10. But actually what we're going to do is we're going to be rounding our mixed numbers to the nearest whole number. So if I really think and break that down, let's see, where am I going to put this? Come down here. If I break that down, I think about this on a number line, right? Well, I know I have the number 3 wholes to start, and then the next whole number would be 4. I know that I have a denominator of 10, so I'm going to break this down into tenths. And let's see, this would be 1/10. So 2/10, 3/10, 4/10. This would be 5/10. And this would be 9/10. So 9/10 would be right here. So 3 and 9/10 would be right here. So if I thought about where I'm rounding that, well, I'm super close to 4. So this rounds to 4. And when I estimate the about product of 5 times 3 and 9/10, well, I know my answer should be around 20. Okay, so that's really the work we're doing. That's it. It's just getting a real good of estimation about numbers, which takes us back to the whole concept of reasonable. Reasonable. Are my answers reasonable, right? We like to estimate first so that when we go and do the math itself, when we do the algorithm and we get the exact answer, we can always ask that question of, well, did I do it correctly? Because if it's close to my estimation, things feel good. If my estimation and my real answer are so far off, then I know something went wrong, something's not reasonable. I need to go back and see what I've done. So let's play the game some more. Let's play more of estimation of whole numbers and mixed numbers, or even mixed numbers and mixed numbers. Let's see what happens today. Let's play around with that. So our next example again, so we're gonna, let me change that. Let's just say round to whole number. That's actually a good way of putting it because it might be that we actually have 2 mixed numbers. Round a whole number, and then we just multiply. And that last one was just for fun because, all right. So let's see, what's another example we could do? What if I took 2 3/4 and I'm going to multiply that by 30 and I don't know, 1/16. That's random. Okay, cool. Well, here you go. They're both mixed numbers. So let's first round both of these to their whole numbers. And again, I may want to just start to visualize what this would look like. Like in this case here, I have 2 and then my next whole number is 3. And with my other number line, I start on 30 and my next whole number would be 31, right? Because we're just counting by ones in all these. And according to this denominator, this part's cut into fourth. So this would be 2 and 1/4. This would be 2 and 2/4. And this would be 2 and 3/4. So that's right here, which again, I'm closer then to 3 than I am to 2. So this rounds to 3. And here, oh, 16. So why did I do this to myself? So that's 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 lines. Okay, there's 16 parts. Well, here's 1/16 right here. Actually, this is 30 and 1/16. That's pretty small. So actually this rounds to 30. Now we're just going to multiply. So 3 times 3 is 9, but it's not 9, or it's not 3, it's 30. So it's 10 times greater. So my answer is about 90. Oh, cool. Sorry, I was squaring that. Made it look like it was 901. So my answer is about 90. So that's it. That's all we're doing today with this. So it's a lot of past skills. And again, it's a big skill of being able to remember how to estimate to help us get an idea of what our answers should be, so that when we do start really multiplying mixed numbers and whole numbers together, then my estimation will make sure I have a reasonable answer. So, hey, let's do another one. I don't know. That's 3/8 times 20, let's say. Okay. So again, I'm just going to mix this up, because if you notice here, this isn't even a mixed number over here. It's not a top heavy fraction. So it's actually just a fraction. So we'll think about in a second what that means. This can be a little tricky, right? This one, which is why I want to do it. So again, we're going to round a whole number. And then we are going to multiply. Now, if I think about this 3/8, if I was to round this to a whole number, this is where it gets tricky. This is again now where we really, oh, you know what? We do have a third step. We just ask, is it reasonable? And we can really ask that when we're really multiplying, but you know, something to keep in mind. Anyway, as I was saying, so if we think about like really what this means, like if we were to round this, like let's talk about this concept. We have something that's smaller than 1. So we're actually going to start at 0. We're going to end at 1. It's cut into 8 pieces. Right? So there's 8 pieces. And then 3/8 would be right here, right? 1, 2, 3, 3/8. And again, as always, if like how I'm cutting up these number lines and doing this work doesn't make sense, please go back and watch the other videos in which we talk about how to put fractions on number lines. So now, again, if we look, the tricky part with this one is that here would be the middle. So if I actually did round this, it would make sense that I actually round down to 0. But one thing we know that if I made this 0 and I multiplied this by 20, I would end up with 0. And that's actually not reasonable, because this isn't 0. It's more than 0. So there's no way my answer would be 0. So with fractions, and this might come up from time to time, right? I know at the beginning of the video, didn't even say that. Don't you love how I threw in this curveball? With fractions, when we get smaller than 1, then what's really reasonable is just, I would always just round it to 1. Right? And then when we round that, we get 1. And 1 times 20 then would be 20. And we actually know how to solve this. We've done this in class. So we could actually see the real algorithm and then ask that question if it's reasonable. So 3 times 20, right? 20 holes with 3 pieces each is 60. Size of the piece doesn't change. That's a division problem. So 60 divided by 8. 6 times 8 is 48. 8 times 8 is 64. Okay, I'll just start with 6. That's 48. That leaves me to, oh, I could do one more. That leaves me with 4. So I have 7 holes. Uh-oh. Up here. So I have 7 holes. This converts to 7 holes and 4 out of 8. Right? So now that's the part that's super tricky, is like, oh, well, was this reasonable? I called this 1, so I got 20, but really when I do the math, it's 7 and 4/8, and those don't really seem close to each other. But it does seem more reasonable than just 0. And I could also say, and bear with me with this, I hope this is making some sense. I could also say, well, yeah, actually it made sense to round it closer to 0. And 7 4/8 is closer to 0 than it is to 20. And 3/8 is closer to 0 than it is to 1. So this is reasonable. And if you're like, what the heck are you talking about? None of that made any sense to me. Don't worry, because we'll come across more problems like this as we go. This is just one of those like oddballs you'll see from time to time, right? So let's move on with what we're really doing, and that's whole numbers and mixed numbers and mixed numbers and mixed numbers and all that other jazz. So let's go back and get back on track with the solid work. Again, we might see that every once in a while, and that's why we took some time on that. So what did we say? We're going to round to a whole number. And then we are going to multiply. And then we could think about, is that reasonable, right? Maybe, but that's only, we can only ask that question if we really know the answer. And we actually don't even have to worry about that today, right? Because we are just estimating. Let's see, 6 and 1/5 times 3 and 4/12. Okay, so come on, I'm gonna round to the nearest whole number. So that's really thinking about the fraction part. And I'm gonna put these down numbers just so we can see them. This is kind of like a glimpse into how our brain's working. We start at 6, we know the next number is 7. Here at 3, the next one will be 4. This is gonna be cut into 5 pieces. And 6 and 1/5 is right here. So as I can see, it's a lot easier to go to 6 than I'm going all the way to 7. So this is going to round to 6. I'll multiply that by 3 and 4/12. So 12. So thirds, 6s, 12s, and then 4. 1, 2, 3, 4. So 3 and 4/12 will be right here. I always like to find the middle. That helps me on ones like this where I'm confused. So there's 4, 5, 6. So that would be the middle. So definitely if it's on the left side of the middle, then I'm staying down. So this is around a 3. And then 6 times 3 is 18. And there we have it. Now we don't know the real answer. So we're not really going to ask that question, is it reasonable yet? But we will be when we start solving these for real. Okay, so let's just do one more and kind of move on. So we're feeling good about this skill again. So how about 5 and 5/6 times 9? Let's just do a whole number this time. So we're gonna round to the whole number, and then just multiply. And we're done. So step 1, I see a mixed number. Let's round that to the nearest whole number. So that's on 5 and 6, 6 pieces. So I'm gonna cut them into thirds first. This would be 5 and 1/6, 5 and 2/6, 5 and 3/6, 5 and 4/6, 5 and 5/6 here. So I'm right here. Well, I'm super close to 6. So this is going to round to 6. I do not need to round this. It is already a whole number. Yay. So 6 times 9 is 54. So when I take 5 and 5/6 and I multiply it by 9, it is 54. And again, if that's reasonable, I guess if we had to ask that question, we could think about it that way. 5 and 5/6. Again, that's really close to 6, but right. So if 6 people each had $9, how much would that be altogether? That could make some sense. So I guess that's one way to like put into a story problem. So that's our job today. That's it. That's all actually we're doing. We think about mixed numbers and whole numbers, and we have to start estimating, right? When we want to get that about, then all we really do is make sure we're rounding our mixed numbers or our fractions to the nearest whole number, but really any fraction we're probably just going to round to 1, right? We talked, but with our whole number or with our mixed numbers, we're going to round them to the nearest whole number. And if we already have a whole number, then we don't have to round it. And then we just multiply those together and we'll figure out about how much that would be. So further ado, I'm going to leave you, and we thank you for another wonderful episode of Math Talk video thing. See, I made that up too. So you got an intro song, and then you actually got a title of all these videos. Called it anything before, which I'm not going to call it that either. I'm just going to let you go. Have a great day. We'll see.